3 Toyota engines, all of them legends, all of them with over 200,000 miles on the odometer, and only one of them came out the other side looking like it could do another 200,000 without breaking a sweat. The 1GR-FE, the 2GR-FE, and the 3UR-FE are 3 of the most respected internal combustion engines Toyota has ever built. They power everything from Tacomas and 4Runners to Camrys and Land Cruisers. Millions of Americans have one of these engines sitting under their hood right now. And the question that keeps coming up, which one actually holds up the longest when real mileage gets involved, has never been answered with a straight, honest comparison. Until now. We pulled high mileage examples of all 3, tore into them, looked at what failed, what didn't, and what the internal condition revealed after 200,000 miles of American roads. The results were not what most people expected. First, why 3 engines specifically? This isn't a random selection. These 3 engines represent 3 distinct engineering philosophies within Toyota's lineup, each built for a different purpose and a different customer. Together, they cover an enormous slice of the Toyota and Lexus vehicles Americans actually buy and drive. The 1GR-FE is a 4.0-liter naturally aspirated V6 engine. It sits under the hood of the Toyota Tacoma, the Toyota 4Runner, the Toyota FJ Cruiser, the Toyota Tundra in certain configurations, and the Toyota Prado sold internationally. In the American market, this engine has been the backbone of Toyota's truck and SUV lineup for years. It produces around 236 to 270 horsepower, depending on the specific vehicle application, and it was designed with one primary purpose: durability under load in rough conditions. The 2GR-FE is a 3.5-liter, naturally aspirated V6 engine. This one has a completely different mission. It powers the Toyota Camry, the Toyota Avalon, the Toyota Highlander, the Toyota Sienna, the Lexus RX 350, the Lexus ES 350, and various other models. It produces 268 to 296 horsepower, depending on the variant and the generation. Where the 1GR-FE was built for work, the 2GR-FE was built for refinement and high-volume consumer use. Millions of these engines are on American roads right now. The 3UR-FE is a 5.7-liter naturally aspirated V8 engine. This is Toyota's heavy hitter. It lives in the Toyota Tundra, the Toyota Sequoia, and the Lexus LX 570. It produces 381 horsepower and 401 pound-feet of torque. It was built to handle maximum payload, maximum towing, and maximum punishment over sustained periods. If the 1GR-FE is the workhorse and the 2GR-FE is the daily driver, the 3UR-FE is the heavy equipment. 3 different engines, 3 different jobs. Same test, 200,000 miles and what's left. The 1GR-FE at 200,000 miles, what the inside actually looks like. The 1GR-FE is a push-rod-free dual overhead camshaft design with Toyota's variable valve timing with intelligence, VVTi, on the intake camshafts. The engine block is cast iron, which is significant and worth coming back to. The cylinder head is aluminum. At 200,000 miles, the first thing that stands out on a well-maintained 1GR-FE is the condition of the cylinder bores. Because the engine block is cast iron rather than aluminum with steel sleeves, the bores resist wear differently. Cast iron is harder and self-lubricating compared to an aluminum block, and at 200,000 miles, cylinder bore wear on a properly maintained 1GR-FE is typically within 2 to 4 thousandths of an inch, well within the tolerance range that allows continued operation without a rebuild. The pistons, connecting rods, and wrist pins show proportional wear, but nothing catastrophic. The timing chain system on the 1GR-FE deserves specific attention. This engine uses a two-stage timing chain arrangement, a primary chain driving the crankshaft to an intermediate shaft, and secondary chains from that intermediate shaft to the intake and exhaust camshafts on both cylinder banks. At 200,000 miles, the chain tensioners, those are the hydraulic components mounted to the front of the engine block and cylinder head that maintain tension on the timing chain links, show some wear on examples that received irregular oil changes. On engines with documented, consistent, full synthetic oil changes at or before the recommended intervals, the timing chain slack measured at 200,000 miles is remarkably low. The chain stretch is there, but it is gradual and predictable rather than sudden. The VVTi actuators on the intake camshafts, the gear-shaped assemblies bolted to the front of each intake camshaft that advance and retard cam timing using oil pressure, show the clearest evidence of maintenance history at this mileage. On engines with clean, regular oil changes, the actuator vane seals remain pliable, and the actuator response is quick. On neglected examples, those same vane seals harden and crack, and the actuators develop slow response or lock in one position. This is the 1GR-FE's most mileage-sensitive component. Overall internal condition at 200,000 miles, genuinely impressive. The cast iron block gives this engine a structural advantage that becomes more apparent at high mileage than any specification sheet suggests. The 2GR-FE at 200,000 miles, where refinement meets reality. The 2GR-FE is more technically sophisticated than the 1GR-FE. It uses dual VVTi. That means variable valve timing on both the intake and exhaust camshafts simultaneously, rather than just the intake side. It also uses a more complex intake manifold with dual runners that change length based on engine speed, controlled by the intake manifold changeover valve, a small actuator located on the upper intake manifold assembly, and it uses an aluminum engine block with cast iron cylinder liners pressed into place. At 200,000 miles, the 2GR-FE tells a more complicated story than the 1GR-FE. The timing chain system on the 2GR-FE has one known weakness that shows up clearly at high mileage. This engine uses a single primary timing chain that drives both bank camshaft drive chains through an intermediate sprocket arrangement. The chain tensioner for the primary chain, mounted at the front lower section of the engine block, is particularly oil pressure dependent. When oil pressure drops during cold starts before oil has fully circulated, that tensioner temporarily loses its hydraulic support, and the primary timing chain can slap against the plastic timing chain guide rail mounted inside the timing cover. Over 200,000 miles of cold starts, that guide rail wears. At high mileage, the secondary timing chain guides on the camshaft drive chains also show wear, and in severe cases, they crack and shed fragments into the oil. This is the 2GR-FE's documented vulnerability. It is not a fatal flaw. This engine has powered hundreds of thousands of Camrys and Highlanders to high mileage without catastrophic timing chain failures. But compared to the 1GR-FE at the same mileage, the 2GR-FE timing system shows more wear and requires more scrutiny. The aluminum engine block itself holds up well, but the cylinder bore finish at 200,000 miles shows more taper wear near the top of the stroke. That is where the top piston ring reverses direction at the top of its travel than the cast iron bores of the 1GR-FE. The difference is measurable but not disqualifying under normal usage. Where the 2GR-FE genuinely excels at high mileage is the dual VVTi system performance and the intake manifold changeover valve function. On well-maintained examples, both VVTi actuator sets remain responsive, and the intake manifold changeover valve actuator, that small motor on the upper intake plenum, continues switching between the long and short intake runner lengths correctly. This delivers the torque curve Toyota designed the engine to produce even at 200,000 miles when the oil has been kept clean. The 2GR-FE is a good engine at 200,000 miles, but it demands more from its maintenance history than the 1GR-FE does. Neglect the oil changes, and the timing system pays the price faster. The 3UR-FE at 200,000 miles, the V8 that refuses to show its age. The 3UR-FE is a different class of engine, not just in displacement, but in construction philosophy. This is a 32-valve dual overhead camshaft V8 with Toyota's dual independent variable valve timing with intelligence, dual VVTi, operating on all 4 camshafts across both cylinder banks. The engine block is cast iron. The cylinder heads are aluminum. That cast iron block again, and this time it's wrapping 5.7 liters of displacement. At 200,000 miles, the 3UR-FE's internal condition is the most consistently impressive of the 3 engines in this comparison. The cylinder bores show wear patterns consistent with high mileage, but the cast iron construction means the wear is slower and more even than an equivalent aluminum blocked engine. The rod bearings and main crankshaft bearings, the plain bearing shells that sit between the crankshaft journals and the connecting rod big ends, and between the crankshaft and the main bearing caps in the lower engine block, show clearances within acceptable limits on well-maintained examples at 200,000 miles. The timing chain system on the 3UR-FE is extensive. This V8 uses 4 timing chains total, 1 primary chain at the rear of the engine driven by the crankshaft, 2 secondary chains driving the intake and exhaust camshafts on each cylinder bank, and all of it managed by multiple hydraulic timing chain tensioners and fixed chain guides made from reinforced nylon. The rear-mounted timing chain drive is a design choice Toyota made specifically to reduce the noise and vibration that front-mounted timing systems transmit through the firewall into the cabin. At 200,000 miles, the rear timing chain system on the 3UR-FE shows wear, but remains within specification on engines that received consistent oil maintenance. The nylon timing chain guide rails, particularly the pivoting tensioner guide arms on the secondary chain systems, show expected surface wear but rarely crack or fail catastrophically the way comparable components can on the 2GR-FE. If you've made it this far, consider hitting the like button and subscribing. It helps bring more content like this to more people who actually care about what's under the hood. The 3UR-FE also benefits from Toyota's use of forged steel connecting rods rather than powdered metal rods. Forged steel rods are more dimensionally stable under high load and high heat cycles, which matters enormously in a truck engine that spends regular time under towing and payload stress. At 200,000 miles, the connecting rod big end bores and wrist pin bores on the 3UR-FE show less distortion than comparable components in lighter-duty engines that used powdered metal rod construction. One area where the 3UR-FE shows its mileage most clearly is fuel injector performance. The 3UR-FE uses port fuel injection. The injectors are mounted in the intake manifold ports, spraying fuel upstream of the intake valves rather than directly into the combustion chamber. At 200,000 miles, Fuel injector flow rates diverge. Injectors that flowed identically when new now show variation of 5 to 10% between cylinders. This doesn't cause immediate failure, but it does affect combustion balance and long-term ring and piston condition on individual cylinders. Cleaning or replacing the fuel injectors at 150,000 to 200,000 miles is the single most impactful maintenance action on a high-mileage 3UR-FE. The weak points that surprised us on all three. Every engine in this test had one common failure pattern that cut across all three designs. The positive crankcase ventilation valve, a small spring-loaded check valve typically mounted on or near the valve cover on each cylinder bank, was compromised on every high-mileage example that showed accelerated internal wear. This component allows crankcase pressure and blow-by gases to be recycled back into the intake manifold rather than venting to atmosphere. When it clogs or sticks open, either crankcase pressure builds and forces oil past gaskets and seals, or raw fuel vapors and moisture bypass the valve and enter the oil supply. On all three engines, the examples with the cleanest internal condition at 200,000 miles had documented positive crankcase ventilation valve replacements somewhere in their service history. The examples with sludge, bearing deposits, or accelerated timing system wear almost always had original, never-serviced positive crankcase ventilation valves, a $10 component, and it separates the engines that make 200,000 miles easily from the ones that don't make it at all. Oil viscosity and what it reveals about long-term survival. All three engines were originally specified for 5W30 motor oil. At 200,000 miles, the story changes. Engines with measurable cylinder bore wear, ring wear, or bearing clearance above factory specification benefit from a move to 5W40 or 10W40 full synthetic oil. The higher viscosity rating, that second number after the W, represents the oil's resistance to thinning under heat. A thicker film at operating temperature fills worn clearances more effectively and maintains oil pressure through the bearing journals more reliably. Every high-mileage example in this test with a known maintenance history that included a viscosity step-up to 5W40 at some point past 150,000 miles showed better bearing condition at teardown than equivalent mileage engines that stayed on 5W30 throughout. This applies to all three engines equally. The clear winner, the 3UR-FE wins. And it isn't particularly close. The cast iron block, forged steel connecting rods, rear-mounted timing chain system, and conservative bore size to displacement ratio give this engine a structural durability margin that the other two cannot match. At 200,000 miles, the 3UR-FE's internal components require less remediation to continue operation than either the 1GR-FE or the 2GR-FE. The 1GR-FE takes second place. The cast iron block gives it the same foundational advantage as the 3UR-FE, and the single VVT-I system on only the intake camshafts is actually a durability advantage over the more complex dual VVT-I setups. Fewer moving parts in the valvetrain means fewer failure points. The VVT-I actuators are the weak link, and they are directly linked to oil maintenance history. The 2GR-FE comes in third in this comparison, not because it is a bad engine, it isn't, but because the timing chain system's sensitivity to oil quality and the aluminum block's faster bore wear rate make it more dependent on a perfect maintenance record to reach 200,000 miles in comparable internal condition. When that maintenance record is perfect, the 2GR-FE gets there. When it isn't, the timing system shows it. What this means if you own one of these. If you have a 1GR-FE in a Tacoma, 4Runner, or FJ Cruiser, the VVTi intake camshaft actuators on the front of each cylinder head are your primary concern at high mileage. Keep the oil clean, never extend oil change intervals, and have those actuators inspected if you ever hear a cold start rattle at the front of the engine that disappears after a minute of idling. If you have a 2GR-FE in a Camry, Highlander, or Lexus RX 350, the primary and secondary timing chain guide rails inside the timing cover are your main variable. Consider having the timing chain system inspected at 150,000 miles rather than waiting for noise to develop. A timing chain service on a 2GR-FE costs $800 to $1,500. A timing chain that jumps a tooth and bends valves costs several times that. If you have a 3UR-FE in a Tundra, Sequoia, or Lexus LX 570, your engine is built to outlast almost everything else on the road. The fuel injectors are the component most worth addressing proactively at high mileage. Have them professionally cleaned or replaced between 150,000 and 200,000 miles, and keep a close eye on oil consumption. If consumption starts rising, address the positive crankcase ventilation valve on both cylinder banks immediately. All three of these engines can reach 300,000 miles. The data from every high-mileage example in this test confirms it. But getting there requires understanding what each engine actually needs, not just what the owner's manual suggests. The winner is clear. The 3UR-FE is built on a scale and with materials that give it a margin the other two don't have. But every single one of these engines, properly maintained, is one of the best reasons to buy a Toyota in the first place. If you're enjoying this video, consider watching the next one, where we break down exactly which Toyota and Lexus engines are worth rebuilding at high mileage and which ones you should just replace.